Everybody, it's Mr. Gustin back in the physics classroom. We are looking at worksheet 2, problem number 1. I'm going to run you through a little example problem here to hopefully help you finish up the rest of worksheet number 2. So here we go. I've got a box and there's a 50 Newton force being applied to it at a downward angle of theta, or 37 degrees. The object doesn't move, and it's asking me to calculate the value of the following forces. Okay, I want to find the force of weight, Fg, the friction force, and the value of the normal force in this problem. Well, let's go ahead and first remember that Fg is equal to the mass times baby g. We learned that from a mass versus weight lab. I think I can probably go ahead and solve for that one right now. If I know the mass, and I always know baby g, it's a universal constant of physics. So let's go ahead and take 5 kilograms, and we'll multiply that by 9.8 meters per second squared. And that will give us our force of gravity. I think it's going to end up being 4.49 newtons, somewhere around 49 newtons. Okay? The other two forces, force of friction and force normal, I'm going to have to do a little more digging with that one. So let's go ahead and move over to our model and construct a force model diagram, or a free body diagram. So here's my object, there's my surface. I know that there's a force of gravity acting on it. It's touching a surface, so there's definitely a normal force acting on it. I'm pushing it downward at an angle, which means I need to make sure that my force shows that downward at an angle. And again, force vectors always start from the object and point away from the object. That's why the arrow looks like it does here. And then if it's trying to be pushed this way, but it says it's staying at rest or it doesn't move, we know there must be an opposing friction force holding that in place. Oh, we'll call this just F. That's what the diagram called F. Now, F, that force, is not acting in one direction alone. It's acting horizontally and vertically. Let's go ahead and label the horizontal component of that force. We'll call it Fx. And the vertical component of that force, we can call that Fy. So the next force on our list is the force of friction. Let's come up with an Fnet expression that contains the force of friction. Let's look. The force of friction is acting horizontally, so I'm going to want to start with an Fnet x. For the force of friction, let's start with an Fnet in the x direction. We know it's not accelerating, it's not moving, it's stationary, it's static. Total force in the x direction is going to be 0 newtons. What forces are acting in that direction? Well, we have the force of friction acting, and we also have that Fx acting, the force applied in the x direction. Okay. What we can see here is if 0 newtons equals the force of friction minus Fx, we also kind of know that the force of friction is equal to Fx. Okay, let's solve for Fx. I don't know anything specifically about Fx, but I know a lot of information about the applied force. I know its magnitude, and I know its direction. So I'm going to kind of substitute in for Fx. Here's what I'm going to do. I'm going to say the force of friction is still equal to F applied times, this is the adjacent side to that angle, so force applied cosine of theta is going to give me my Fx, which in turn is going to tell me my force of friction. So let's check that out. Force of friction is equal to the 50 Newton applied force times the cosine of 37 degrees. Now, this is your chance to make sure your calculator is in degree mode, because if it's in radian mode, we are not going to come up with the same answer. So double check, make sure your calculator is in degree mode, and if not, and you're not sure how to change it, why don't you go ahead and watch a YouTube video to figure out how to change your specific calculator into degree mode. But 50 cosine 37, I end up with the force of friction being equal to 39.9. I'm going to pop that right over here. Force of friction is 39.9 newtons. How did I do it? I identified the force of friction was in the x direction. I wrote out my Fnet expression, and then I substituted in my force applied, cosine theta, for Fx, and went ahead and solved it from there. All right, let's go ahead and try the last one. I'm going to erase this. We'll keep the force of friction right there, but I'm going to erase this, and we'll go and look at Fn. Following the same logic as force of friction, let's look and say to ourselves, which direction is Fn in? Fn is in the y direction. So let's come up with an Fnet in the y direction. It's not moving, it's not speeding up, it's not accelerating, so my Fnet is going to be 0 newtons. What forces are at play? Well, Fn is pointed up, so Fn minus all the forces pointed downward. So pointed downward we have Fg, and we also have F applied in the y direction. This component is pointed down. So Fy is down, Fg is down, but Fn is up. Quickly, I can go ahead and say all the forces pointed up should be equal to all the forces pointed down because they together net 0 newtons. So I'm going to make a quick algebraic change and say Fn equals Fg plus Fy. Fn equals Fg plus Fy. Let's go ahead and make one substitution because I don't know anything about Fy, but I know a heck of a lot about the force applied. So the normal force is equal to the weight of the object, or Fg, plus the force applied times, this is the opposite side, sine theta. Let's plug some numbers in. Do I already know what Fg is? Yeah, I do. It's right there. It's 49. 49 newtons plus 50 newtons times sine of 37 degrees should give me my normal force. Let's see what we get. I end up with 79. The normal force, Fn, equals 79.1 newtons for my normal force. And again, this is all of my forces downward should be equal to that normal force. The normal force is the opposing upward force that we have there. 79.1 newtons. I think I've answered my question. I want to point out one last thing. One big thing that we see here when we compare A and C is that the force of gravity is not always equal to the normal force. This is a common mistake among students learning physics for the first time. They think because gravity pulls an object down, the normal force supports it and cancels it out. Some students reference Newton's third law where all forces are equal and opposite. This is not a third law pair, so no, Fg is not always equal to the normal force acting upward on the object. You should have the tools now to go through and finish worksheet number 2. Ask your teacher or email your teacher if you have any further questions.